Okay, so in this video I just want to talk about slicing software, and in particular Prusa's slicing software. Um, in previous videos we discussed how to basically get or obtain or make an STL file. But now what we're going to do is we're going to go to the next step, which is taking that STL file and make it into a toolpath that your 3D printer can follow. Now, this is going to be, aimed at the Prusa software and Prusa printers. However, the slicers are quite similar and they might be laid out a bit differently, but some of the key concepts are the exact same. You just might have to work around the settings a bit further. Now, what you'll need to do first of all, if you have a Prusa printer, you'll need to download the PrusaSlicer software. As you can see here at the time of this video, 2.5.0 is available. You can download for Windows, Mac or Linux, depending on what you have, what operating system. Now I already have it downloaded. As soon as you have it downloaded, you'll be able to open up that software. So I'll just open up ours now. And it will look like this as soon as you've opened up. What you can do then is you can look at your settings. Just ensure the type of printer that you have is selected over here on the right hand side. For us, we're going to be dealing with the original Prusa Mini and Mini Plus. Now, more than likely, you'll either have this if you have a Prusa machine, or you'll have one of the i3 Mark IIIs. They're a bit larger. As you can see, if I select this, it gives us a larger build plate to put our object on. But what we're going to be doing is using our Mini because it's plenty size and it's the one that we have available. What you can do then is also select the filament you're going to be using. Nearly always you're going to be using PLA. It's the easiest plastic to get your hands on, as well as it's the one that the majority of printers use. Now you might also have ABS or some other variation of plastics, but you need to tell your 3D printer what plastic you intend on using. Now more than likely it's going to be PLA, so we can select Prusa PLA and we can leave our printer settings here alone. If you want, you can change these, which will just change the layer heights, and you'll know what layer heights mean as we move a bit further. Now what I'm going to do is I'm going to move in our STL file. Now you can drag and drop onto the build plate the STL file, or you can go over here and go to files and you can import an STL file by going over here. What I'm going to do is I'm just going to drag and drop the STL file that we were talking about in the previous video, which is our wheel, our cart wheel. So when I drop that in there, it loads up. This is our STL file. We can actually drag it around the build plate itself. So this plate below here represents the surface on which the 3D printer will build on. Straight away I noticed that this is not in an optimal position to print. So what I'm going to do is I'm going to change the orientation. So I'll make sure that my object is selected. As you can see, it's selected because it shows these outer perimeter right angles. I can go over here to my rotation. I can click on that and then I get the 3 different axes of rotation. I'm going to go with this red one. I'm going to bring it up and click it on 270, and it's going to rest nice and flat on the build plate. Okay. I can click out my rotation and then I'll put in a location I'd like it to be. Now if I had multiple of these, I could right click and basically copy and paste them. So I can just Control C, Control V, and you can see that you can duplicate them as well like that. And now we don't want to, so I'm just going to leave it to one. So I'm going to delete this one and just put this one here around the center. What we can do then is we can go back over to our settings. We'll now go to supports. We will not need supports. Supports are basically to support anything overhanging. So for instance, if this was up at an angle, so if I move this back up to the position it was in, I would need supports if I was to print it like this, because for instance, you wouldn't be able to print underneath the object. So here in in thin air, it would end up just the plastic would end up dropping down, as well as around here it would start to droop down. So for instance, if I had to print it in this orientation, or the object had overhangs no matter what way you orientated it, you could put in these supports. Now I'm just going to put these supports in real quickly, and we're going to go back to where we were before just to show you what they look like. So as you can see there, that's the supports that we'll put in place. It decided that it doesn't need supports inside here. So we'd have to go back, because we know that it would droop down there as well. We'd have to go back to our supports, and we'll put supports everywhere. I'll press slice now again. And now you can see that it has put supports everywhere that thinks it needs supports without it drooping down and giving us a failed print. So what I'm going to do is I'm going to change this again to none. And I'm going to change my infill. Now, percentage infill is basically what percentage the inside of this object is plastic. So I can go down to my bar over here on the right hand side, and I can actually drag this down. As you can see, it's just showing me the different layers that the 3D printer is going to print. You can see that inside it, it is hollow. And depending on what percentage you give here, change the percentage infill of the object itself. So what we want to do is we want to ensure that this object is in the right orientation. So we're going to go again to our orientation. We're going to bring it all the way down to 270, so it's flat in the build plate. We're going to say that it needs no supports. We're going to go with, let's say, 20% infill. Now that's kind of fairly normal to 15 or 20, because I know that this is going to take a small bit of weight, but that weight is going to be of the toy card that I'm making, or the cart itself. So I know that it's actually not going to be taking much pressure. So 20% plastic inside of it will be absolutely fine. If for whatever reason that fails on you, you can always go back and reprint it and increase the infill. I strongly suggest not ever going above 60%, because past really, 30, 40%, you don't really get any extra structure for the additional plastic you're putting into it. So for this, we'll just go with 20. Brim, if you take brim, all that's going to do is give you a wider base surface. So it's actually going to do the very first layer and make it quite wide. And the reason that you'd want brim, you'd never want it for a print like this. But for instance, if you're printing something skinny and tall, you need a big wide brim base, which would help that from falling over during printing. So we actually don't need brim, so we'll leave that ticked off. So that's pretty much all the settings that you have in the very simplistic version of the slicer, and it's all you really need. So what we can do now, I'm quite happy with that. I can go to my slice now, and it will slice my object. It's in the orientation I like. I can see that there's a nice thick outer shell. I can bring down along my layers by using the bar up here, if I want to, as you can see. And I can see that it has, within the center of it, has 20% infill. So you can see that there's 80% of it is actually thin air. And as I bring it down, I can see all the different layers. So if I just go down to the very first layer here, you can see this is what it should look like after the printer has laid down the first layer of plastic. Then after the second layer of plastic, third layer, and when it builds all the ways up, we should have our finished object. Now I'm quite happy with that. It also tells me, after slicing this piece of software and giving me this toolpath, down the right hand side, it also tells me the estimated time. So it says here it will take 28 minutes to finish this print. I think that's acceptable. If, for instance, you have quite a large print and you don't have too much time, and it says here, oh, it's 6 hours to print if it's something quite large, you can go back and you can lessen infill, or you can even change the quality. So you can change it to something larger, like 0.25 millimeters, which is draft, and that will be a thicker layer height and the machine will run faster, and that will actually increase or decrease the time taken to print this object. Now all you have to do is export your G-code, and then you can save it directly to a USB, which you can then take over to the 3D printer itself.